So this week we are looking at week 9, okay, which is on simplifying, and we're going to do a little bit of approximating with radicals as well. Right? Like if I asked you what's the square root of 13. Okay, it doesn't come out to a nice number, but I'm going to show you how you can get an estimate, not a super accurate estimate, but a pretty close estimate by hand. Okay. All right, so there are different ways to simplify square roots. Okay? If you have a method that you use now and it works, I would just stick with the method that you're using. If you have trouble with square roots, I'll show you the method that I use. Okay. Does anybody simplify square roots by like breaking it up into a factor tree? Has anybody done that before? Yeah, some people. Okay. So if that method works for you and you like that, then I would just stick with that method. If you have trouble with the factor tree method, I'm going to show you how I do it. All right, so you guys already have this part written down. We're just going to write down the examples in a second. So the goal is when you are trying to simplify a square root, you have to take the number and write it as a product. That means you're going to take the number and write it as something times something. You can't just pick any two numbers you want, though. All right, like for example, if you wanted to simplify the square root of 20, you could say, well, it's 10 times 2. But that wouldn't help you with the method I'm going to show you. If you want to simplify the square root of 20, which we're going to do in a second, you have to pick a number that's in that list. Okay? And it keeps going. Okay? These are all the numbers that you can take the square root of easily in your head. Like the square root of 9 is 3. The square root of 16 is 4. These are all what you call perfect squares. Right? So using my method, you have to break up what you want to simplify into two numbers, and one of them has to be a number in that list, and the list keeps going. All right, I just stopped at 81, but the next one would be 100, 10 times 10. The next one would be 121, 11 times 11. Right, you can go as high as you want. Generally, the problems that I give you, you're not going to have to go too much higher than that to break up the numbers. Okay? It starts to get kind of hard if you go that much higher. All right, so let's look at the number 20. All I want to do is see if I can break up the number 20 into something times something, and I'd like one of the numbers to be in that list. Does anyone see how you can break up the number 20? Yep?
10 and 2.
Okay. Are those numbers in that list?
No.
No. So 10 and 2 won't work for this method.
Oh, I thought.
Anyone see another way we could break up the number 20? Yep.
4 and 5.
4 times 5. Yep, perfect. Okay, so 4 times 5. Now there is a second step. We're not doing it yet. We're just practicing breaking up the number first. Okay, so if we were going to simplify, that's the first step. 4 times 5. All right. How about 50? Okay, again, you might think 10 times 5, but 10 and 5 are not in that list. So does anyone see how you can break up the number 50? Something times something, and one of those numbers has to be in that list. Yeah. Well, does 7 times 8 give you 50? No. And those numbers aren't in that list. So we got to find two numbers that multiply to give you 50, and one of the numbers has to be in that list. They both won't be in the list, but one of them will. Yep. 25 and 2. Yep. So when we start to simplify that square root, which we're going to do in the next step, that's going to be our first thing we do. And how about 80? This one's a little tricky, but does anybody see two numbers that multiply to give you 80, and one of them has to be in that list? And if we weren't sure what number it is, how could we use a calculator to help us figure it out? What could we do starting with the first number and a calculator to see if it would work? Oh, Eli?
You can multiply those numbers to see if they...
Right, what if we're not sure how to, but we have this list of numbers? How can we check if one of these numbers in the list would work? with a calculator. All right, I want to know if 4 times something is going to give me 80. Yep.
You could do 80 divided by like one of the numbers on the list.
Right. You could just take the number you're trying to simplify and divide it by, let's start with 4. If it goes in without a remainder, then that's your answer. It works. Okay. So let's take 80 divided by 4, 20. So that is one way you could do it. You could write it as 4 times 20, and that would work. But there's a bigger number in this list that goes into 80 besides 4. Preferably, if you can find the biggest number, it's going to be easier later on. Does anybody see a number that's bigger than 4 that goes into 80? Yeah?
16.
Yeah. And if you weren't sure, just, again, start dividing. If you think it's 9, let's check 9. No, 9 doesn't go into 80. And then let's check 16. Yes. So how would we break up 80 using 16? Oh, that one? How would we break up 80 using 16? So we want to break it up into one something times something, like we did the first two.
Like times 5?
Yeah, what times 5?
16.
Yeah, 16 times 5. Okay, so that's your first step. Try to break up the number that they give you using what's up above. Okay. Let's just try one more of those. Let's try one more, 120. All right. How about Derek? How could I use my calculator to start checking which of those numbers in that list are going to be a factor of 120?
Divide 120 by the numbers of numbers.
Yeah, let's try 4. 120 divided by 4. Okay, so we know 4 works. Let's try some of the other numbers and see if those work. Mia, what would be the next one I could try? 9. So let's see if 120 divided by 9 works. No, that one gave me a decimal, so 9 doesn't go into it. So Leigh, what would be the next one we could check?
16.
Yeah, we could check 16. That one's not going to work either. Okay, 16 doesn't work. 25, no, 25 would go into 125, but not 120. And you can keep trying, but I don't think you're going to find. Whoops, I did skip one number in that list. I just realized 36. So just put that in right below it. Oh, actually, you know what? I messed up. Cross out 26. Put in 36. It's not 26. So 36 doesn't work. 49. There's no other number that's going to work. Okay, so it is 4. And does anybody remember what we saw? 4 times what was 120? About Landon. 4 times 430. Yep, exactly. All right, so that's your first step. All right, now let's do the second step. After you break up the number you're trying to simplify, we're going to actually take the square root. All right, so we'll use our calculator if we need to for that. So let's start with 20. We already broke it up into 4 times 5. Okay, so that's the first step. Now what you want to do is take the square root of each number separately. That's how you finish it off. So you're going to take the square root of 4 times the square root of 5. Okay, one of those we can simplify, one of them we can't. Does anybody know which number here we can simplify? Either the square root of 4 or the square root of 5? Yeah, we can simplify the square root of 4. Okay, when I say simplify, I mean something we can do in our head without a decimal. Can anybody tell me what's the square root of 4? Yeah, 2. 2 square root of 5. And that's your final answer. And the way you can check to make sure you did it right is type in the original problem, square root of 20. That's what you get. Now type in what you think the answer is. 2 square root of 5. They come out exactly the same. That means that you simplified it correctly. Okay? So simplify does not mean to write it as a decimal. I'm just doing this to check that my answer is right. So 2 square roots of 5 is the final answer. All right. So let's try 50. Okay, how did we break up 50 before? Ben, what did we break that up into?
25 and 2.
Yep, exactly. We break it up into a 25 and a 2. That's usually the hard part, figuring out how you're going to break it up. Now take the square root of each number separate. Square root of 25 times square root of 2. Which one of those is going to simplify in our head? Square root of 25 or square root of 2? But Wyatt, which one of those is going to simplify? Okay, what's the square root of 2? So because that one's a hard one to do in your head. Well, how about the other one?
5.
Yeah, square root of 25 is 5. So we get 5 square root of 2. And if you type that in on your calculator, you could check it. But it's definitely right. All right, so let's try square root of 80. Katie, how did we break up 80 before? We broke it up into what times what?
4 times 20.
So we did do 4 times 20, and we found that that would have worked, but then we found an even bigger number.
16.
Yeah, we broke it up into 16. So let's break it up into the biggest one that we can. Okay, 16 and 5. I'll show you what happens in a minute if you do 4 and 20. Okay, you're not wrong. It's just you're going to have an extra step. Okay, so 16 and 5. Take the square root of each number separate. And Ryan, which one of those is going to simplify nicely?
16.
Yep, what's the square root of 16?
4.
4 square roots of 5. And again, you can check your answer by typing in 4 square root of 5. You get about 8.94. Type in square root of 80. You get exactly the same thing. So that means we did it right. Okay, let's look at 80 again for a second. Okay, keep in mind what the answer is. It's 4 square roots of 5. If we break it up into 4 times something, that's fine, okay? Because 4 is a number in that list, and I said you could pick any number that was in that list. So you got square root of 4 times square root of 20, and the square root of 4 is 2. The problem with that is this part right here simplifies again. Okay? We know square root of 20 simplifies because that's a problem that we did earlier. All right. So if you don't pick the biggest number that you can in that list, you're going to have to do the process twice. Okay? So let's look at what would happen here. How did we break up square root of 20 earlier? Anyone remember what we used? Yep. We did 4 times 5. So what I did here is I broke it up the first time, simplified it. Now I'm breaking 20 up a second time, and I'm going to simplify it. This part simplifies. What's the square root of 4? Yeah, someone said it? 2? Yep. So we've got that 2 in front. We got another 2 from what's circled right there. And 2 times 2 gives me 4. So if you don't pick the biggest number in that list, it's okay. But then you have to do the process more than once. If you pick the biggest number you can, you're done in less steps. Okay? But 4 square root of 5 is exactly the same answer. Okay? Just more steps. All right, so any question on that idea? So now, we're going to look at doing the same thing, but what happens when there is a letter. Okay. I'm going to show you the first step, just like we did before, and then we'll do the second step. The first step is going to be to break it up as a product. Okay? You're going to write it as something times, well, maybe more than one product. Once we break it up, we want to use as many powers of 2 as we can. Okay? So I'll do the first one, kind of show you guys an example, and then see if you guys can do the other two. If you want to break up x to the 5th, the key is we have to break it up using as many exponents of 2 as we can. So you would break it up into x to the 2nd times another x to the 2nd times an x to the 1st. That's how you break it up. That's using as many powers of 2 as I can. Now, how did I know that? Well, I know when I'm done, all the exponents that I write down have to add up to the number I started with. Okay. So 2 plus 2 is 4, plus 1 is 5. All right, so you want to use as many exponents of 2 as you can, and then you might be left over with an exponent of a 1, okay, if it's an odd number. All right. Let's try y to the 4th. Anyone think they can tell me how I would break up y to the 4th? Using as many powers of 2 as I can, and then maybe a power of 1 if there's anything left over. Yeah.
Y to the 2nd and another y to the 2nd.
Yep. Perfect. Okay. You can only break it up into something with a power of 2 or something with a power of 1, right, to do the method I'm going to show you. You can't use anything else. And if you add up the 2 plus 2, perfect. You get 4. All right. Let's look at z to the 7th. Anyone think they can tell me how to break up z to the 7th using as many powers of 2 as you can? Yeah. Yep, z to the 2nd, z to the 2nd, z to the 2nd, and then you're left over with a z to the 1st. Perfect. The reason we're going to break it up like that is because something nice is going to happen to all of those. The z, well, that's just going to be left over. But anything that has a power of 2, it's like it's going to cancel out in a second. Okay, so now let's look at the last step. So you break it up, just like we did up top. Now, for each letter that has a power of 2, so like all the ones I circled in blue, the square root and the power of 2 are going to cancel each other out. All right, so let me show you on the first one. So write down first what we had up above. Take the x to the 5th and break it up into as many powers of 2 as you can. And what you're doing now is you're going to take the square root of each one of those separately, just like we did up above. Square root of x to the 2nd, square root of x to the 2nd, and square root of x. So it's exactly what we did with numbers. Take each number and write it with its own square root. Except now you might have more than 2. You might have 3. Okay. Now it says for each letter that has a power of 2, so this one and this one, the square root and the power are going to cancel out. So what's going to happen? That's gone, that's gone. That's gone, that's gone. So now the only thing you have left in front is an x and an x. And that square root of x, nothing happened to it. It's like it was left over. So we have to leave that. When you multiply x times x, that gives you x to the what power? X times x. Yeah. Yep, perfect. X to the 2nd. That is how you simplify the square root of x to the 5th. Okay. And again, there's other ways to do it. If you have a way that you're used to using, you can stick with that. If not, Hopefully this helps. All right, let's try the next one. Y to the fourth. First step is to break it up, just like we did up top. Y squared times y squared. Now take the square root of each one separately. Square root of y squared, square root of y squared. What's going to happen everywhere that we have a square root and a power of 2? But Ayla, what's going to happen there? Everywhere that we have a square root and a power of 2.
I don't know.
Right? What does it say up above? It says for each letter that has a power of 2,
So they cancel out.
right, the square root and the square are going to cancel out. So does anything cancel in this first one?
The 2.
The 2 and the...
The Y.
No, the y is going to stay, but the 2 and the... Want to help her out? What's going to cancel with that 2? Yeah,
The square root.
right. The square root and the power of 2 cancel out. That's the square root. That's the power of 2. All right, let's look at the next one. Anything there that's going to cancel out? Well, what do you think? Anything there that's going to cancel?
Yeah, the other one.
Yep, the 2 and the...
And the square root.
Yep. So we have a 2 and you have a square root. So Eli, what's left in this first one?
Nothing.
No, there's something there. Not everything
Or
canceled.
just the y.
The y. And what's left in the second one?
The y.
The y. And what's y times y?
2y.
Y to the
2.
second power. And that's how you simplify that one. All right, let's look at the third one, z to the 7th. We're going to first break it up, but we already did that up above. Z to the 2nd, z to the 2nd, a z to the 2nd, and a z. I usually skip this step, and I go right to writing it like this. Because you're basically just copying it over, but you're breaking it into 4 rather than all together. So we have z to the 2nd, z to the 2nd, z to the 2nd, z to the 2nd. Okay, Acadia, what's going to happen in the first one?
Isn't the last one just Z?
Oh, yes, thank you, it's just a z. Yeah. So what's going to happen in the first one?
Square root of 2.
Yep. In fact, everywhere there's a square root in the 2, they're all going to cancel. The last one does not because it's just a z. It's just left over. And we're left with a z times a z times a z. That's z to the 3rd power. And this last one, you just copy it down because nothing happens to it. So that's how you simplify the square root of z to the 7th. All right. Let's try one. We don't have to do all of them, but let's try one that has a number and a letter. Same idea. Okay. We're just going to separate it into 2 problems right away. You're going to separate it into the square root of 75 times the square root of a to the 6th, and you're going to do each one of those problems separately. So now it's like the problems we had up above. We're doing 2 problems separate. Okay. Let's start with 75. Does anybody see a number from this list that you can use to break up the number 75? Yep. 25 times
3.
3, perfect. Yep. So we're going to break it up into the square root of 25 times 3. Okay, we'll do that problem. And how about the square root of a to the 6th? How can we break up a to the 6th using as many powers of 2 as possible? Yeah.
Excuse me, 8 to the second 3 times.
Yep, we're just going to have a to the second 3 times, because 2 plus 2 plus 2 gives me 6. And now simplify what you can. Square root of 25 is 5. Square root of 3, well, we're just going to leave that because we can't do anything with it. And then square root and square cancel. Square root and square cancel. Square root and square cancel. A times A times A is A cubed. Now you can leave your answer like that, and I think IXL will mark it right. But what they usually do is they put everything that doesn't have a square root in front, and they put everything that has a square root at the end. It's just reordering it. But again, what we had up above there, that is still right. Okay. All right, let's take a look at the last one. So I put a chart to kind of help you guys with square roots if you get stuck on some of them. These are all the numbers that are in that list. 1, 4, 9, 16 on the other page. And it goes even higher. All right, so let's say we want to estimate the square root of 50. The first thing we want to do is just kind of estimate what 2 numbers it's between. So we say, all right, let's see, square root of 16 is 4. Well, we're looking for square root of 50. Well, the closest thing we have is square root of 49, but that's too small. So we know that it's going to be between 7, because 7 times 7 is 49, and 8. Okay, it's going to be between 7 and 8. And the way we could check what it is now, because 7 times 7, that's just a little too small, try 7.1 times 7.1. That's basically all you do, is you figure out what 2 numbers it's between, and then check an answer. I don't think it's going to be like 7.3 or 7.4. I think that's going to be too big. So when we multiply this out, 1 times 1 is 1. 7 times 1 gives me 7. 7 times 1 is 7, and 7 times 7 is 49. Add that all up. Okay, that's pretty close. I was trying to get 50 exactly. I got 50.4. So I would say to the nearest decimal, 7.1 is approximately the answer. You wouldn't want to go 7.2 because that would be even bigger. It would be even further away from 50. Okay. So estimating a square root, it's not the quickest process, but you just have to kind of figure out the 2 numbers it's between. So let's look at 75. What times what? Or what times itself is smaller than 75? Anybody see the 8? Yeah, so 8 times 8 is 64. And then 9. So I don't know exactly, but it's between 8 and 9. I might guess like 8.7. Try 8.7 times 8.7 and see how close you are. That's how you estimate a square root by hand. That's it.